This is a linear actuator that I built from like easily attainable off-the-shelf parts. So I've got a stepper motor, a flexible coupler, a lead screw, a copper nut, 2 chunks of 12-inch linear rod, and then some linear rod holders and linear rod bearings. And the yellow stuff is printed PVA to kind of hold it all together. So what I'm testing here is the ability to accurately go back and forth. So the program I'm going to run, the G code I'm going to run, is going to push it out 50 millimeters at a feed rate of 50 millimeters a minute. Then it goes another 50 at 100, another 50 at 200, and then it goes back 50, 300, returns back to where it went at 400 millimeters per minute, and then it does just move to 150 and back again. So I'll run it and show you how it works. So here we're going slow. One of the concerns I had with this is it doesn't have very much power. So if I was going to do this again, I would put a gearbox on the stepper to give it some more power. The other thing is that it probably should have encoding, so that you know if you've got if you've stopped or jammed it. The nice thing about this is that you could use it in place of a hydraulic, right, where you don't have to run hose, you just run electrical wires. So now we're getting very close to the look, now we're going at double speed, 100 millimeters per minute. At 135, it switched to 200 millimeters. So at 185, it should reverse. And now we're running at 300. And there you can see it at 0. And now this is at the maximum speed. You can see that the Gerbil controller is giving it acceleration, deceleration. I hope that was interesting.